Hello, this is Dr. San Abdullah with the course Data Structures, Algorithms and Generic Programming. So the topic which we are covering in this video is generic programming and the subtopic is Standard Template Library or STL. So we are at lecture 2B. So the supplemental website for this course is easymcq.com/goget. So basically this website is a learning management system and it has these wonderful features listed before you, and these features will facilitate and make it very easy for you to get the most out of this course. To do this, I would suggest you look at these 6 videos available on the course website. So now we move on to the supplemental website. So we are at the supplemental website. As you can see, there are standard and core computer science courses, and of course cutting edge courses are also here, like natural language processing, AI, machine learning, and so on. So we move on to the course of our interest, which is data structures, algorithms, and generic programming. And we see the topics here which have already been covered. So as I said in the lecture 2A, that I'll start with generic programming, and then I'll show you how we can work at the subtopic level also. So this lecture is for the subtopic level, STL, Standard Template Library. So we go there and start from there. We have 4 questions and answers. So what is a standard template library or STL in C++? So basically, it has containers, it has algorithms, it has iterators, function objects, smart pointers, and so on. So it has many things, and these are the key components of the STL. And of course, they help us as programmers to develop powerful applications. And you need to have deep understanding of everything, and that's where we excel as programmers. So let's go into the details. So STL, of course, stands for Standard Template Library, and of course, it is the STL is the standard template library in C++, and it provides a set of common data structures. So it has data structures and it has algorithms that are template based, and they allow generic programming. Okay, so these are very powerful features. So we have the containers. So we have sequence containers, associative containers, unordered containers, and container adapters. So some of which was covered in lecture 1, 2A, and we are covering some of them here also. So we have the container adapters like the stack and queue and priority queue. So we have a separate topic in this course on priority queue, and there's a topic stack queue and list also. And we have the algorithms also. So it provides algorithm for sorting, it provides algorithm for finding or searching, and it provides algorithm for transformation or manipulation. So sorting will be covered a lot in this course, and quite a few Q&A. So this is a very powerful thing, and it's already been there, and it helps us to cut down on our coding time. Okay, so let's look more into it. So it has the collection of algorithms and iterators for traversal of the container elements, looking for something while we are iterating through the containers. And of course, depending upon the type of the containers, the iterators could be bidirectional, like a doubly linked list, okay, or random access iterators like an array, and of course for input and for output and so on. So then there are function objects. So we have classes that overload the operator. So that operator overloading will cover in lecture 2C, and I'll give you the examples also. And of course, these allow to customize the operations. So there are a lot of powerful things are there. And then the smart pointers manage dynamic memory automatically. Okay, or dangling pointers which are not pointing anywhere. So quite a few powerful features are there in the C++ standard template library. All right, so let's move ahead. So if you want to know more, here it is. So what are the benefits of using STL and C++ and give example? Okay. So the benefit is the code reusability. So that cuts down on the development time significantly and efficiency, because the in the library, if it's sorting, the sorting techniques has already been optimized. They have already been made efficient, so that the programmer spends more time on actually implementing where the sorting is required instead of writing the sorting code, and that results in generic programming. So we are basically the underlying structure and the data, how it is stored, that is hidden from us. Generic programming, ease of use and standardization. So when we are saying I've used the sort from STL, then we know that how it's going to perform, because if people write their own sorting techniques, it's their choice. Then how do you standardize it? A rich set of features and improved maintenance. So maintenance is also simple because standardized things are being used. And then the safety. So let's look into more detail. So code reusability, implementation of common data structures and algorithms, reducing the need to write custom code. No need to write custom code. Writing custom code is one thing, then fixing it, maintaining it, debugging it, that takes lots and lots of time and a lot of effort goes in. And these built-in functions lead to faster execution than custom implementations because they have already been optimized, allowing developers to write functions and classes that work with any data. Okay, with because of these templates, ease of use, making it easier to manage collections of data that I've already explained. So, and of course, I already explained the rich set of features. Improved maintenance, how the maintenance is improved, because components can improve code readability and maintain. If I can read the code which is written in a standard form, okay, by some by excellent programmers, then of course it is very easy to maintain, relatively very easy to maintain. And safety, STL provides smart pointers and other constructs that help manage memory effectively, reducing the risk of memory leaks and dangling pointers. So it's highly desirable that STL is used. And here is an example. Okay, so we have used the algorithm STL. Okay, and where it was used? It was used for sorting purposes. It was used for sorting purposes, right? And we don't have to write anything on our own. Understood or not? So this is the way we use them and use them effectively. Okay, now things have their pros and cons also. Nothing is perfect. So what are the issues, if any, of using STL in C++? Well, learning curve. It takes a while to get used to the STL library because of the complexity, because of the variety, and because of the diversity also. And there is the performance overhead. Since there is generic programming, so that may not be very optimum because customization is optimum. Generality cannot be optimum. And then is the overhead in the iterators. Maybe some certain iterators were used which add to the overhead as compared to writing on our own. Okay, debugging challenges, template errors, type errors. I will go into it. Limited control over memory management. So if the issue is managing the memory or to reduce the memory and to allocate the memory to customize, that is not in my control because I'm using STL. That's the thing. Lack of customization of container behavior and algorithm limitations are there. So since I'm using the library, okay, I'm using a certain algorithm, so and I'm not happy with it, or I am aware of the limitations, so I end up writing my own, so I cannot like customize it. Compatibility and portability issues, compiler differences across different machines, different platforms, different operating systems, and then of course the variation in the standard libraries themselves. So let's go into the details. So learning curve, okay, may be complex for beginners due to use of templates, iterators, and algorithms. Okay, and of course, it takes a while to get a solid grasp on C++ fundamentals. But this is the one-time investment. Generic programming, it can lead to increased compilation times, bloated code. Bloated code means a lot of code, and which could have been reduced, which need to be compiled also. So that may impact the build times and the executable size of the binary code because it's already bloated. And some iterators, those selling associative containers, may introduce performance overhead instead of direct array access. And of course, maybe I have a use case in which direct array access is more desirable due to performance reasons. But I am forced to use iterators, so how can I get the type of performance I'm looking for? Then the debugging challenges, the errors related to templates can produce long and complex compiler error messages, which not only makes it difficult to comprehend and make sense out of the error, but also debugging becomes more difficult. And misusing STL containers, type of errors, can lead to subtle type related bugs. Subtle type, and the more subtle the bug is, the more difficult it is to identify. And once it gets identified, then you can fix it. But the first task is identifying the bug. Memory allocation, they manage STL manages memory automatically, which is of course it is beneficial, and which doesn't result in dangling pointers. And but performance performance critical applications where the performance is linked with the availability of the memory, usage of the memory, efficient usage of the memory, then it becomes a problem. Then it can become a problem. All right. Then is lack of customization. Okay, lack of customization, obviously when it is pre-packaged, it is pre-coded, it is pre, so how can I do the customization? Then it may require what? Extending or wrapping STL components. So wrapping will, I have a Q&A in which wrapping is covered. And then are the compatibility and portability issues. Although this is standardized, but some implementations may have very fine or subtle differences, okay, in performance, in behavior, across different compilers and across different platforms. So I'm referring to platform as per the different operating system or a different hardware platform also. And these features or optimization may vary between different versions of the library itself. Okay, so when not to use the standard template library and when to use it, when not to use it and when to use it. That's a very interesting question. So what's the interesting answer? When not to use STL, performance critical applications, because the performance, there is the customization is not in my control as a programmer. So I need to customize it to meet certain performance requirements. I cannot do that. So there's the overhead. Then is the memory constraints. Memory constraints as in dynamic memory management. I cannot do this. Okay, but I'm required to do it. Specific requirements, custom behavior, customization is difficult because everything is pre-packaged. Simple use cases, overkill for basic tasks. So overkill means that a lot of effort and coding, a lot of effort and processing goes into doing something which is very simplistic. That's an overkill. Legacy code basis, integration issues, how to integrate STL based code with the code which is older code without STL is a nightmare. Inflexible iteration, custom iteration requirements cannot do this because things are fixed. Limited compiler support with reference to older compilers, okay, which do not support it. And the template errors. Let's go into some details. So performance critical applications, why you don't do it? Because that can introduce overhead, okay, which may not be acceptable in real time or performance critical applications. So hand optimization. Actually, we may end up actually hand coding everything. So machines cannot do this. So dynamic memory management manage memory automatically, which can lead to inefficient memory usage. Automatic does not guarantee efficient. It ensures that there are no dangling pointers, but never there was no promise of efficient memory management. And when the resources are limited, as in embedded system, this becomes a problem. Custom behavior, if the application has unique requirements, okay, they cannot be met by STL containers. So better implement custom data structures and algorithms. Do it yourself, bug it, debug it, and then the maintenance issues are there. Simple use cases for simple tasks like using static array or fixed size using STL may add unnecessary complexity and dependencies. So, and this is actually overkill. Legacy code bases, systems that already are traditional data structures and patterns. Integrating STL may be complicated, and then the maintenance issue and the compatibility. It may not work together effectively and efficiently. Inflexible iteration. Inflexible iteration. If you need highly specialized iteration patterns that are not well supported, then implement your own. Do your own thing. Okay. And some older compilers may not fully support the latest features of STL, which can limit its use. Okay. And debugging complexity, template errors. The use of templates can lead to complex and hard to read compiler errors, making debugging a nightmare, especially for the beginners. So, STL has its own pros and cons. So, should use or should not use STL? Well, uh, one thing is for sure. As a programmer, you should be aware of the pros and cons and use as per the requirements and as per the limitations and as per the scenario. That's the most effective way. And since we don't have more than 4 questions, so these buttons are dimmed out. So that's all for this topic. Thank you very much.